Hi students, welcome to my channel. Myself is Vedamurthy. Today we are going to discuss about the modern periodic law and the present form of the periodic table and the nomenclature of elements with atomic number more than 100. In the previous video we have studied about the how the why the required elements are to be classified and how the periodic classification was exist, what are the laws are applicable on existing for the periodic classification. There are Dobrynin triads, that is law of triads, and one more law is law of octaves, that was given by Newlands, John Alexander Newland. And later we studied about the Mendeleev's law and his predictions of the elements which are kept is blank, aluminium and silica, that is he called as, after later it was found as gallium and germanium. This is about the previous part. So today in this class we are going to talk, as I said early, a modern periodic law and present form of periodic table, and one more subpart is nomenclature of elements with the atomic number is more than 100. So first we'll discuss about modern periodic law and present form of the periodic table. Student, we must bear in our mind that when Mendeleev developed his periodic table, a chemist knew nothing about the internal structure of the atom. However, the beginning of the 20th century witnessed profound developments in theories about subatomic particles. In 1913, the English physicist Henry Morley observed the regularities in the in the characteristic of X-ray spectra of the elements, and he plotted the graph square root of V, where here V is the frequency of X-rays emitted against the atomic number Z, which gave a straight line, and not the plot of the square root of S, so square root of V versus atomic mass. Here, from that, the atomic number is a more fundamental property of the element than its atomic mass. In the previous class we studied about atomic mass, and this class we are going to talk about elements which is having the atomic number. The atomic number is more important fundamental property of to identify the element than its atomic mass. So as per Mendeleev's periodic law is therefore accordingly modified. So this is known as the modern periodic law and can be stated as like the physical and chemical properties of the elements are periodic functions of their atomic numbers. I'll repeat again. The physical and chemical properties of the elements are periodic functions of their atomic numbers. This is the modern periodic law against the Mendeleev's periodic law as slightly modified. The periodic law revealed important analogies among the 94 naturally occurring elements. So Neptunium to plutonium, like actinium to proactinium, are also found in the pitch blende on ox of uranium. So it stimulated a renewed interest in inorganic chemistry and has carried out into the present with the creation of the artificially produced short-lived elements. You can recall that the atomic number is equal to the nuclear charge that we studied in the second chapter, that is number of the protons, or the number of electrons is a neutral atom. It is easy to visualize the significance of the quantum numbers and electronic configurations in periodicity of elements. In fact, it is now recognized that the periodic law is essentially the consequence of the periodic variation in the electronic configuration. Indeed, determine the physical and chemical properties of elements and their compounds. So numerous forms of the periodic table have been derived from time to time. So some forms emphasize chemical reactions and valence, whereas others stress the electronic configuration of the elements. A modern version is so-called long form of the periodic table of the elements is the most convenient and widely used. That you can see in the this is the one modern periodic table which is having the long form. Okay, students. The horizontal rows, here you can see that horizontal rows which we called as series uh, that was given by the Mendeleev are called periods, which are the horizontal rows. These horizontal rows, these are horizontal rows. These are called as series in the as per Mendeleev's. Now we can change in the long form or modern periodic table. It is considered as periods. And the vertical columns uh, are called groups. These are the vertical columns towards this. These are the vertical columns. So these are called groups. So elements having similar outer electronic configuration in their atoms are arranged in vertical columns. Which are the elements having the similar electronic configuration? Those are arranged in the vertically those are arranged like this. So those are referred to as groups, which are vertically arranged. Those are we can refer to as groups or families. We can call it. According to the recommendations of the International Union of Pure and Applied Chemistry, that is IUPAC, the groups are numbered from 1 to 18, replacing the older notations of the groups 1A, 7, 2A, 3A, 3B, 4A, 7A, continuously like that. So there are altogether 7 periods. So the period numbers correspond to the highest principal quantum number n of the elements in the period. The first period, sorry, yeah, the first period contains two elements. The first period contains two elements, that is 1A and 1B, lithium and beryllium. The first period. So the subsequent periods consist of the 8 and 8 18, 18 and 32 elements respectively. See, you can see that one, there are first here two are there, the second row onwards it was changed to um, 8 8 is there, and next 18 18, and the third is this is will 32. So the seventh period is incomplete, and like the sixth period would have a theoretical maximum on the basis of the quantum number of 32 elements. In this form of the periodic table, the 14 elements of both the 6th and the 7th period, lanthanides and actinides respectively, are placed in separate panel at the bottom. This is lanthanides and actinides, that is separately placed in the periodic table. So now we are to uh, how we can name these elements more than 100 which having the atomic number. So that is we can call it as nomenclature of the elements. The naming of the new elements had been traditionally the privilege of the discoverer, and the suggested name was rectified by the IUPAC. In recent years, this has led to some controversy. The new elements with very high atomic numbers are so unstable that only minute quantities, sometimes only a few atoms of these, are obtained. So their synthesis and characterization so therefore require highly sophisticated and costly equipments and laboratory which we can identify. So such work is carried out with the competitive spirit in the laboratories in the world. So scientists, before collecting the reliable data on the new element, at the times get tempted to claim to discover For example, both American and Soviet scientists claimed credit for discovering the element 104. The American has named it Rutherfordium, and Soviet scientist has named that Kurchotovium. So to avoid such problems, the IUPAC has decided to recommend that to name the new elements so discovered. So after that it was named officially. First you have to temporary name you have to give, then after that IUPAC system they are in the representatives will give the permanent name. So very systematically the nomenclature be derived directly from the atomic number of the element using the numeric roots for 0 and numbers 1 to 9. So these are shown in this table. These are shown in this table. So we can call here. So 0 is nil, and so symbolized as abbreviated as n. So digit 1 we can note it as for the digit 1. So name we can call it as un, and abbreviated as u. So same way 1 2 3 4 9 up to 9 is there. And this particular table will solve one more problem in this same video. So then we can call it as in different like that. So table 3 point this one notation of the IUPAC nomenclature of the elements. So for the digit 3, so we can call it as tri, and it is abbreviated as T. Digit 4 we can call it as quad or quadrant, that abbreviated as Q, and so on up to 9. So ninth one is ENN, and we can abbreviate it as E. Thus, the new element first gets a temporary name with a symbol consisting of the 3 letters. Later, the permanent name and symbol are given by the vote of IUPAC representatives from each country. The permanent name might reflect the country or state of the country in which the element was, where the element was discovered, in which country or which state. So, and also on the base of the, to pay a tribute to the notable scientist, we can name it, we can name the permanent name as per IUPAC regulation. As of now, elements with the atomic number up to 118 has been discovered, and official names of all elements have been announced by IUPAC. So students, you can see in the second table here in the nomenclature of elements with atomic number above the 100. So here you can see the table. In this table it is given like this. See, for example, if atomic number is 101, so then name accordingly the temporary name it can it was given like this: anilimium, anilluminum. So this symbol is like this UNU, and as for IUPAC official name, it was given like this Mendeleev. So that is IUPAC symbol is MD. Same 103 atomic number having unitritium, so you can call it, the symbol is UNT, and so that official IUPAC name is lawrencium, and its IUPAC symbol is LR, and etc. You can study this in the table. Students, here one problem you are going to be solved in this particular question about the notations of the IUPAC nomenclature of the elements as given in the table. First, this one. Students, here the problem is, what would be the IUPAC name and symbol for the element with the atomic number is 120. See, from this table, so 1 is UN. See, here they are given atomic number 120. So 1 is UN, and for the 2 is BI. Okay, students, and this abbreviation is B for 2 and 1 for U. So where for one more, so 0 which is carrying NIL is the name, and abbreviation is N. So totally we can call it as 120. The name we can write it like this: unbenilium, unbilinium. So the symbol is UNB. You got the students? Understood, no? See, for example, see 120 is the atomic number they are given. Even we don't know the 120 what is the actual element, but not yet discovered. So the question is like this: is for 120, what if the atomic number is 120? What would be the IUPAC name and symbol? Like the question is, for example, for here one we can put it as UN, and 2 you can put it as BI as per this table, and 0 you can call it as NIL. Okay, so totally we can merge all these things, we'll get the answer unbilinium. What will get? Unbilinium. So that is symbolized as UNB. Students, I hope this unit is part of second part is understood. Thanks for watching the video.